Hello, class. I hope we're having a wonderful day. Right, so today we're going to get started on section 2.2, distribution types, right? So by now you should have already, read, skimmed, gone over section 2.2, and definitely have, have completed homeworks 1.1 and 2.1, right? And what we've learned in those sections we'll be applying here today again, right? So like I said before, right, it all builds up on each other. It all builds up on each other, right? So before we get started, right, some type of graphs, right? We're gonna be dealing with these bar graphs, all right? We're used to seeing these bar graphs, right? Here you'll see that they're called histograms, right? And the definition of the histogram, just in case you're wondering, this is page 57 of your book, page 57, right? The definition for the histogram is a graph that displays the data by using contiguous vertical bars, unless, of course, the frequency of a class is 0, so, there won't be any height, right, of various heights to represent the frequencies of the class, right? So, right, so in other words, what we're going to be doing in this section is graphing, right? Pretty much bar graphing, right? X and Y axes and everything, right? And we'll get into more of that, right? One thing I wanted to look at, right? Not the skewers on the left, right? Not the skewers on, at least not yet, but the graphs, right? We have three types of graphs, right? Let's start with A. We'll start with A, right? Whenever the graph is lobbed, right? Whenever it's higher on the left and tapers out to the right, right? Imagine if you were to, there's a definition for this type of graph, right? There's a definition to this type of graph, right? Imagine there's a sharp end right there, right? Imagine that there's something sharp, right? Of course, this side isn't sharp, right? So one way to remember this is like a skewer, right? These things that the skewers that we stick in food, vegetables, to put on the grill, right? To eat, right? If you see that the sharp point is pointed to the right, to the right, it's like having a skewer pointing that way, right? And of course, this is going to be called a right skewed graph, right? A right skewed graph. That's one, right? That's one name. The other name is called positively skewed, right? Another way you can also tell is, where is this skewer here that I drew, right? This one that I drew here, where is it pointing at? Is it pointing to the left or is it pointing to the right, right? And whenever we're dealing with a number line, right, to the right is positive, to the left is negative, right? So it's positively skewed, it's right skewed, right? So, and you can use whatever helps you out, right? I'm just, trying to help those who might need, a little bit more push. Not push, but, and here, let's go to C, right? Let's go to this one down here. Let's go to that one right there. Right? That one, if you notice, it gets high from here, but it tapers out that way, right? It's sharp on the left, right? It's sharp on the left. So that is going to be left skewed, right? Left skewed, or in other words, it's negatively skewed, right? Because it's pointing, this skewer is pointing in the left direction, right? In the left direction. And of course, I have B, right? Which is, hey, that's symmetric, right? And you'll see lots of these graphs, right? These terms, you're definitely going to see them through the remainder of the class, right? Whenever we're graphing different types of data, right? Different types of data. So if you see something that's balanced out, symmetrical, right? That is, there you go, symmetric. If you see a graph that does something like this, right skewed, and if you see something that does this, it's left skewed, right? So there we go. Now let's get started, right? We're gonna start off with the basic one, right? The histogram, right? So the histogram is what I like to call the basic one, right? It's going to require some work, right? It's going to require some work, but not a lot of work, right? But it's still going to require some work, right? Go ahead and close this out. Right, closing all these windows out. Thank you. Okay, so, and here, right, we are giving my column has class limits, and right next to my class limits, I have frequency, right? The number of bears killed in 2010 for 52 counties in Pennsylvania is shown in the frequency distribution table below, right? And the goal here, right, what I'm asked to do is to construct a histogram for the data provided, right? A histogram for the data provided. And if you notice, again, we did a little magic here, right? And for this histogram, I've gone ahead and created another column with my class boundaries, right? And from homework 1.1 and 2.1, we did a few of these examples, right? So I've gone ahead and created my class boundaries column. And what I'm going to go ahead and do now is I'm going to create a graph, right? So I'll call this my graph, right? And probably a little bit larger, right? Oh, no. Let's do this. Right, where the y-axis, right? I'm sorry, your x-axis, right? My x-axis is this one, right? This is my x-axis, right? That one right there is my x-axis, where that is going to be my class boundaries, right? My class boundaries, and my y-axis, right? My y-axis is that one right there. This is going to be my what? My frequencies, right? That's going to be my frequencies. And now the values for my frequencies, right, would be, if we look at the graph, it looks like we got 2, 0, counting my frequencies. It looks like they go up to 20, right? So say this is 10, that's 20. This is 0, and I'll say 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 12, 14, 16, 18, right? And I'm going to go ahead and split. I'm going to go ahead and take my bottom part, right? We got, let's just say we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And so I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect, right? Perfect, right? So this middle part right here, right, that's going to consist of 0.5 to 25.5, all right? This other part here is going to consist of 25.5 through 50.5, and so forth, right? So, in other words, each one of these column entries, or each one of these bar entries, is going to be for each class, right? It's going to be for each class, right? So the first class that I have is it's a frequency of 18, right? So I'm going to go all the way up to 18. I'm going to go over and meet there, right there. The next one, it's going to be right from 26 through 50, all right, or 25.5 through 50.5. That is going to be 12, right? And the next one would be 7, which is somewhere here. And the next would be 6, 2, and 3. 6, 2, 3 would be somewhere like right there. Right? 0, right? So whenever it's 0, there's really nothing, you don't build a graph, right? It has no height, right? Then the other one is going to be 2, right? It's going to be 2 again, so something like this. And the last value is 0, and then the second to last value is 0, and then the last value is a 2, right? So I have something like this, right? I have something like that. Let me see if I can shape these in, right? So and here we go, right? Here it is shaded in, and this is it, right? This is all that's required, right? And now we have an option, right? Is this symmetrical? Is this left skewed? Or is it right skewed, right? Right, if we were using the explanation I used earlier, right, it's broad here, it tapers out that way. This side here is my sharp end, right? My sharp end, right? And it's sharp to the right, right? So this is going to be right skewed, right? This is a right skewed graph. So we're like, you know, like I said, so far it's pretty straightforward, right? You're pretty much just getting the data, the frequency that you found, and you just put them in bar graphs, right? Pretty much bar graphs. And this one is known as the basic, the histogram. Now let's move on to the second case, right? Let's move on to the frequency polygon, the midpoint, all right? The midpoint. Okay. And for the frequency polygon, right, the midpoint, we are going to have to find the midpoint for each class, right? And how we find the midpoint for each class is we gather the lowest value, add it to the highest value, and divide by 2, right? From our previous homework. So, for example, right, for class 1, let's do here, let's do midpoint, right? It is going to be 1 plus 25 divided by 2, right? This is going to give me 26 divided by 2, which is 13. So my midpoint for the first class limit is going to be 13, right? For the second one, right, I have here 26 plus 50 divided by 2. This is 76 divided by 2. This is going to be 38, right? So the next one is going to be 38. And when we go ahead and do the midpoints for all of them, you'd see that you should get 13, 38, 63, 88, 113, we are 138, 163, 188, 213, and 238, right? 238. Now what I'm going to do now, it's pretty similar to what I did earlier, right? I'm going to get my y-axis, right? And your y-axis is going to stay the same, right? Your y-axis is going to stay the same. This is frequency, right? And I know it goes up to 20, right? So I'll go by jumps up 2. That's 10. Oh, that's a little bit too high, right? That's 0 down here. So let's say 2, 4, 6, 8, 10. Very nice. 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. Let's do 12. 14, right? Very nice. I'm gonna go ahead and just write them all out. And 0, right? And you might be asking yourself, hey, what are my ticks for the bottom value, right? Well, the ticks for your bottom value are going to be the midpoints we found, right? So the first one is going to be 0. The following one is going to be, let's say, 13, 38, 63, 88, 113. We are 138. 163. Right, second here. 163, 188, 213, and 238. Right? I have them all listed there. Right? And this is going to be a dot and line graph, right? So it's not going to be a bar graph, right? This is not going to be a bar graph, right? So for the first class, right, I had my midpoint was 13 and my frequency was 18. So that's going to go up there. Right, and at 0, there was nothing at 0, right? So that's going to be a 0. At 38, I had 12. At 63, I had 7. And so forth, right? Right, at 88, I had 6. At 113, I had 2, and so on. And it's going to give me these points, right? And if you notice, the heights are going to be the same heights as your histogram, right? So, and now the best part, right? Connect the dots. Ta-da, there you go. Right, so this here is the frequency polygon graph, or the midpoint graph, right? There's no shading in, it's just dots and connect them. Let's go on, move on to the second one, which is going to be the Ogive graph, right? The Ogive graph, right? And the Ogive graph is a graph that represents the cumulative frequencies for the classes in a frequency distribution. So that right there already tells me a lot, right? We're going to have to do those later examples we did on the previous homework, right? Where we still need the class boundaries, right? We're going to need the class boundaries, right? So let's go ahead and, right, for the data that we have, we would have to find them. But since we are short on time, I can go ahead and get these here, right? Get them here. Let's do, right, because it's still the same problem, just applying the different graphs. The Ogive is right there. Right, so we already have the class boundaries. Those are my class boundaries. There we go. Okay, now I have my class limits, I have my class boundaries, and I have my frequencies, right? What I need to go ahead and find now is going to be my cumulative frequency. Give me 1 second. Right, my cumulative frequency, right? But before I do, right? But before I do, I need to go ahead and give that cumulative boundaries column, right? Which from earlier we said was less than, right? It repeats less than, and it's going to be all the columns, right? All the values on the left side of this column, right? So it's going to be less than 0.5, less than 25.5, less than 50.5. And again, right, I don't want to go ahead and bore you. You can go ahead and pause this, but we're going to do a little magic. Ta-da, right? There we go. Less than 50.5, less than 75.5, less than 100.5, and so forth, right? Oh, no, I forgot one. Give me 1 second. There we go. That'd be 125.5, right? So now that I have that column, right, I'm going to go ahead and now I can go ahead and get my cumulative frequencies, right? Let's go ahead and do that, right? So anything less than 0.5, right? Anything less than 0.5 would be 0, right? So let's go ahead and make this a little bit bigger, right? A little bit bigger. There we go. Let's go ahead and do something like this. That would be 0. Oh, and I also forgot, I'm missing my last one, right? We're missing the last one. For here, it should be less than, right? Here it should be less than that largest most up here, right? The most bottom right. So this should be less than 250.5, right? And there we go. Let me have those frequencies. So anything less than 0.5, right? That's going to be 0. Why? Because in my class limits, everything between 1 and 25 was 18, right? So anything below 1, right? Anything less than 0.5 would be none, right? 0. Anything less than 25.2, that's going to be 18 plus the previous part, which is 18. Anything less than 50.5, that's going to be that 12 plus what was previously, well, from the one from the previous row, which is 18, gives me 30. So therefore, this is going to be 30 plus that 7, right? So that's going to be 37. And if that's 37, then that means this is going to be 43, meaning this is going to be 45, right? Meaning this here, let's see, 1, 2, 3, 4, 5, 6. Okay, yeah, this is right. Plus 2 give me that. Plus 3 gives me 48. Plus 0 still gives me 48. Plus 2 gives me 50. Plus 0 still gives me 50. And at the end, plus 2 should be 52, right? And we said that this value here, right, should equal the same value there, right? They should both equal, right? The largest value of your cumulative frequencies, right, should equal that value. So I know we're on the right track, right? We're on the right track. Let's go ahead and make this a little bit smaller, right? Let's go ahead and make this something like that. That looks good, right? Now, what I'm going to do is create a new graph. Let's go a little bit this way. A new graph, right? Where the y-axis, right? The y-axis, this is going to be my cumulative frequencies, right? Cumulative frequencies, which is that column right here, right? So that's going to go between 0 all the way up to 52. Wow, all the way up to 52, right? Go ahead and make it a little bit more straight, right? That's going to go all the way to 52. So let's go ahead and fill that in, right? I'll say that is 50, right? This is 0. Therefore, this is 25. And if I'm jumping by 5, this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, meaning somewhere up here is a 52, right? A 52. Right, those are jumps of 5, meaning this is 5, 10, 15, 20, 25. Right, something like that. Now, the y-axis, right? This y-axis is going to be my cumulative points, right? So in other words, these points right here. So 0.5, 25 point. Where did that come from? 25.2, right? 25.2, 50.5, and so forth, right? So this here is going to be 0.5, 25.5, we'll do 2.5, 5. And right, we'll get the idea, right? So at 0.5, I'm at 0, right? I'm at 0. Actually, I want to keep this going. There's a reason, right? Oh, so that's 100.5. This is 125.5. Right, this is 175.5. This is 225.5. Aha, finally, 250.5. And you'll see the trend this graph ends up doing, right? And cumulative frequencies, right? So this is going to be a 0. The next value is an 18, right? So somewhere like up here between 15 and 20. For 50, I am at 30, right? So I'm going a little bit higher, right there. Then the next value is 37. The next value is 43. Then 45. Right, and then 48, 48. 48, 48. Then we have 50, 50, and 2. 50, 50, and 52, right? And of course, right, this is the fun part. Let's go ahead and connect the dots. Something like that, right? There you go. And you always see it do that, right? You always see it go up and flatten, right? Go up and flatten, right? And if we've been keeping up, right? If you've been watching the news, right? Flattening, right? The curve, right? So that's what this graph is doing, right? Now, let's go ahead. So this information, right? If we notice for the histogram, for the polygon, and for the ogive, right? This is data that has already been presented, right? It's boom, it's right there. Class limits is there and frequency is there, right? It was the same thing here. Class limits was there, frequency was there, and so forth, right? But now as we're approaching more, the later part of section 2.2, we're going to be given just like raw data, right? Just numbers. And it's going to be up to us to put all of this together. And so when it comes to, if you're listening to this, right? If you're listening to this part, keep watching the videos, right? Because this is where I end up dropping information regarding what's coming up and right, what may come up in the test, right? So it's like being in class, right? It's like attending live lecture, right? So in the test, I wouldn't give you just a, hey, find the width, hey, find a column of class boundaries, right? That's too straightforward, right? That's too simple, right? What I would test you on is something like this, right? Where, hey, you are given raw data. I need you to construct a distribution table with 6 classes, right? So this will really be hinting at yesterday, right? If you were giving a number of class, you're supposed to find the range, right? So then you can go ahead and find the width to construct the table yourself, right? So this is what I'm looking for in your work, right? You're given raw data, and by the questioning, right, you're able to put everything together, right? You're able to gather all your knowledge, right, that's led up to this, to put everything together and show your skills, right? Show your great statistics skills, right? So this is the part, example 4, where we put everything together. So the number of faculty for a variety of private colleges that offer only bachelor's degrees is listed below, right? And of course, whenever I end up giving you this on the test, you're not going to get ridiculous numbers like we got in 2.1, right? Because I think in 2.1 we had like 10,578 for one value, and we probably had like values in the 10,000, and we had like 20 values, right? No, you're not going to get none of that, right? Because that's not what you're being graded on, right? I'm going to give you something probably like this, or a little bit with less numbers, right? I want to know that you understand the section, that you understand the work, that you know how to put everything together. No, there's not going to be it's going to be a closed notes test, right? It's not going to be open book. So these formulas and these definitions, you do have to memorize, right? You do have to memorize. So let's get started, right? So the first thing I would need to do to get started, right, would be, is this formula. Width is equal to range by number of classes, right? So I need that width, right? I need that width so I know the distance between my classes, right? That is my width, the distance between the classes. So we said range is going to be the largest value subtracted by the smallest value in my data, right? If we look at the hundredths place for all of these, we'll see that 309 is the largest. And if you look, you'll see that this is the smallest, right? And by all means, right, if you want to go ahead and use Excel, please send your data to Excel, and you can go ahead and arrange them like we did yesterday, right? So 309 minus 70, right? 309 minus 70 divided by number of classes, and this was given to me, right? Number of classes, that was given to me. This is going to be 6, right? And 309, right? We get 309 minus 70, right? That's going to give me 239 divided by 6. That is going to give me 39.83, right? But what did we say yesterday? Or what did we say yesterday? We said that we always round up, right? You need to round up to the highest integer, to the highest next whole number, which would be 40, right? So my width is 40, right? So my width is 40. Let's go ahead and erase this, right? So now I know that my width is 40, and I have 6 classes, and that's exactly what I need, right? That's exactly what I need. So let's go ahead and draw a class. Limits. And it's the smallest value going, right? So it's 6 of them. So 2, 3, 4, 5, 6. And it's going to be 70 plus 40, which is 110. 110 plus 40, which is 150. 190. 230. 270. And 310, all right? Right, and then so if this is, and remember those rules, right? I cannot overlap, so it must be 70 to 109, 70 through 149, right? 50 through 189, 229, 69, and then 309, and there's only 6 classes, so I don't need to worry about that. Okay, right. So here are my class limits, right? And now let's go ahead and find my frequencies, right? Let's go ahead and find my frequencies. How often, how many numbers are there in this data between 70 and 109, right? 70 and 109. And let's cross them out, right? 70 and 109. I only see 1, right? I only see 1, so that's going to be 1. Right? Let's do between 110 and 149, right? 110 and 149. So that's going to be 1, 2. That's all we have? Yeah, that's all I see. Oh no, there's another one here, 3. Right? So it's going to be here, 3. All right, and what you could go ahead and do is after you count it, then you can go ahead and cross them out. And let's go ahead and do some magic. And there we go, right? So for the first class, I had 1, second class 3, 5, and so forth. And then ended up getting, right, let's go ahead and sum these up, right? So my total here would be 4, 9, 9 plus 6 equals 15, 15 plus 3 plus 2 is 5, so this is 20. And if you count your values, right, you always want to count, right, in case you go over by a little bit. I did go over by 2 whenever I was doing this earlier, so you just be sure that you count correctly, right? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Hey, this is correct, right? I am on the correct path. This is 20, right? And hey, what were we asked to do, right? You're asked to construct a frequency distribution with 6 classes and a histogram. Well, I'm back. We just did all the work for a problem like this, right? We did all the work for a problem like that, right? No, not this one, that one right there, right? And of course, what I would do next would be find my class boundaries, right? My class boundaries. Let's go ahead and do that. All right, and let's do some magic, right? Well, we know this one here is going to be 0.69.5, and this is going to be 109.5, and we'll be right back. And ta-da, magic, right? And here we are. Here are my class boundaries, right? Those are my class boundaries there. And right, what do we got to do now? Well, we said it's a histogram. That's the basic one. Once I do my class boundaries, oh, that's right, right? Once I do that, my frequencies are my frequencies is the y-axis, right? Yeah, right? My frequencies, right? And then what was the x-axis, right? My class boundaries, right? So my frequencies go between 1 and no higher than 6. So let's just say 8, right? Let's keep it simple, right? 1, 2, 3, 4, 5, 6, 7, 8, right? And we said that each one of these bars was going to represent a class, right? So this class here would be 69.5 between 109.5 and so forth, right? So there should be, let's just say 2, 3, 4, 5, 6, right? 6 ticks for 6 classes, right? Right, and you can go ahead and draw it something like that, right? Something that shows the right. You are going to have to show this on your test. 109.5 to 149.5. Right, 109.5. Right. Be sure to include all these on your test, right? And you need to show all your work. So for the first class, right, I get 1. That's a 1. For the second class, I get a 3, so I'm going to go up to 3. For the other one, it's a 5. For the other one, it's a 6. For the other one, it's a 3. Okay. The other one is a 3. And the other one is a 2. All right. Something like that. Right? That looks okay. All right. Let's go ahead and shade this in. Go ahead and shade all that in. All right. And now, what is this? Is this left skewed, right skewed, or symmetrical? Right? This here would be, and you should have options, right? This here would be partially symmetrical. we notice that it is not left skewed, it's not right skewed, but it's none of those, but it's not completely symmetrical. It's just partially symmetrical. So, right, we have answered all the questions, right? So be sure you know how to do one like this, all right? We're just giving values and you're given either the width or the number of classes, and you can set up this table, right? And why, you might be asking, hey, they gave us classes here. What do you mean? Well, if we recall, I forgot what question from the previous homework. It was the other way around, right? They gave us width, and we needed to find the number of rows, right? The number of classes. So we did the same formula, right? We just solved it differently. So width is equal to range divided by number of classes. So very important formula. And to continue, right? To continue the last example, we're going to be dealing with relative frequency, right? Relative frequency, right? So the number of bears killed in 2010 for 49 counties in Pennsylvania is shown in the frequency distribution below. Construct a histogram using relative frequencies, right? So we're not going to be using regular frequencies. We're going to be using relative frequencies. And what is relative frequency, right? To find relative frequency for a class, right? And I think I have that here to the left, right? Yes. It's up here. The formula for relative frequency is the class frequency divided by the total frequency, right? So for first class, I have my relative frequency is going to be 15 divided by 49, right? Let's go ahead and plug that in. And this is again going to give me, let's do 2 decimals, right? And let's round up. So this is 0.306. This is going to be 0.31, right? So that's going to be my relative frequency, 0.31, right? For my second class, right, this is going to be 11 over 49. And this is going to be 0.224489, but only 2 decimal places. So this is going to be 0.22, right? And you're going to do this, you're going to create a new table with all this information, right? With all this information, right? So that is going to be, we said here 0.22, right? And remember, these values must be positive and they must be bounded between 0 and 1. It cannot be less than 0. It must be a decimal point. It could be 0, right? Let me go ahead and clarify that, right? It could be 0, but it cannot be 1 or more. And you'll see why, right? So let me go ahead and find those values real quick. And ta-da, we're back, right? So here are my cumulative frequencies, right? 0.31, 0.22, 0.10, 0.08. And like I said, it could be 0, right? Because if your frequency is already 0, if you were to 0 divided by a number would always give you 0, right? That's like saying I have 0 things in my hand and I'm going to distribute that to everybody in this class, right? There's 20 of you in this class. How many pieces does everyone get? None. I had none to begin with, right? So now that these are all decimals, I'm going to want you to add these up, right? I'm going to want you to add these up, and you can tell you're on the right path because the sum of your relative frequencies must equal to 1, must equal to 1. And yes, there may be errors due to rounding, right? So if you get something like 0.99 or 1.01, that's okay, right? It may happen, right? Because, due to rounding. So let's go ahead and add those all up. I got 0.31 plus 0.22 plus right? And here I got 0.99. And that's okay. I'm close, right? I'm pretty much there. It's pretty much 1, all right? If you got something like 0.98, check your values, all right? You may want to check your values. If you got something like 1.10 or 1.25 or even anything greater than that, right? Because it's happened to me, right? It's happened to me a lot of times. Check your numbers, right? Check your numbers whenever you're plugging them in, because sometimes where most points get taken off are you accidentally forgot to plug in the point in the calculator, right? You, instead of typing 0.31, you put in 31, right? So keep an eye keep your eye out for that, right? And the other part you're going to need here is going to be for the histogram, the basic, right? It's class boundaries, right? Class boundaries. So let's go ahead and get that, right? I can get that from here, right? Because it's for the same values. It's 1 through 250. Go ahead and copy that. I'll go ahead and plug that in here. Where's that? Oh, it's right there. What happened? That's odd. Okay, let's go here. There we go. Okay, so here are my class boundaries. All right. And where this differs from the, from all the previous problems is your y-axis is the one that's going to be different, but your x-axis will still be the same, right? So your x-axis is still going to be 0.5 through 25.5, right? This second one will still be 25.5 through 50.5, right? This here should be 50.5 through 75.5, and so forth, right? Right. The values that are going to change are going to be here. Right. If the sum is 1, right, and each one of these values are by its 0.08, 0, 0.4, actually it's 0.31, right? So that means I can probably go, I would probably do, let's just say 0, 0.05, 0.10, 0.15, let's do 0.05, 0.20, 0.25, we'll do 0.30. 0.31 is the highest, all right? So we'll do 0.35, all right? And it's a histogram, right? It's the basic. So it's going to be the bar graph, right? So for my first cumulative frequency is 0.31. Ooh, that's nice. Somewhere up there, right? The second one is 0.22, somewhere about there, right? The other one is 0.10. Ooh, much lower. The other one is 0.08, a little bit higher, but not that much. All right. 0.04. Ooh, much lower. 0.08 again. That's awesome. 0. Ooh, there's nothing there, right? 0. This keeps going, right? So we'll do something like this. That's a 0. The next one is 0.08. Right, so somewhere like up here, right? The other one is 0 again. And the last one is 0.08. So something like that, right? And it ends there. So like something like this. And clearly we see this is tapering out this way. So this is right skewed, right? Right skewed, or positively skewed, right? So you might be asking, hey, Professor, really the only difference was that we had to find the cumulative frequency. Other than that, it was the same thing as a histogram, right? Yes, that is correct. It's the exact same thing. You just have to find the cumulative frequencies by using this formula. And like how it's shown here, you may be asked to find the cumulative frequencies with the polygon or the ogive, right? So let's go ahead and keep an eye out for that, right? Let's go ahead and keep an eye out for that. So this is where we're going to end this today, right? And if you have any questions, please let me know. And oh, sorry, this is not cumulative frequency. This is relative frequencies. I'm sorry. I'm not sure why I keep saying cumulative. So this is relative frequencies, relative frequencies. I'm sorry. But yeah, if you have any questions, please let me know. If you want these notes, let me know. I'll go ahead, and if I get enough people asking for the notes, I'll go ahead and send them that way. Good luck, right? Hope you had a great weekend. Let's go ahead and finish strong with 2.1, 2.2, and 2.3. Thank you very much for your time, and I hope you enjoy the rest of your day. Thank you.